Hi guys, welcome to this page of the notes, and what we're going to do is we're going to continue to use the properties of isosceles trapezoids to help us solve some problems, and maybe even set up some algebra problems that we would then have to solve. So here we go, let's take a look at this one. I give you trapezoid P, Q, R, S. P, Q, R, and S. I ask you, look at this, same side interior angle postulate. This is going back to the chapter where we talked about parallel lines cut by a transversal. What does that have anything to do with trapezoids? Well, please notice, I have two parallel lines. Let me extend my parallel lines. Boom, there's my parallel lines. Those parallel lines are cut by a transversal. There it is right there. So, what does the same side interior angle postulate have to do with this? Well, here's what it's going to do. I know that angle P and angle S are same side interior angles. So, based on that, same side interior. We also call them consecutive interior angles. Either name, whatever you want to call them, the property is the same. Same side interior angles, consecutive interior angles, they have to sum to 180 degrees. Interior angles sum to 180 degrees. What this means is that angle P plus angle S have to equal 180 degrees. This guy right here and this guy right here have to sum to 180. That's what the same side interior angle theorem says. Well, I already know angle P. I told you it's 77. So 77 degrees plus angle S equals 180. Subtract 77 to the other side. Angle S is 103 degrees. Hold up. I didn't ask you to find angle S. I asked you to find angle R. And once again, really important information, isosceles trapezoid. What do I know about the base angles of an isosceles trapezoid? Yeah, the property says that those angles are congruent. So, angle R is congruent to angle S, which means angle R is equal to 103 degrees. Once again, using properties that we just learned about trapezoids and information from a previous chapter or section coming back and needing to be used and understood to help us solve a problem for the current content we're working on, which happens to be isosceles trapezoids. So really, really important that we're not just doing something and remembering it long enough to pass a test or get through a quiz or a homework assignment, but you really want to make sure that as we're moving through these chapters that you're remembering all of the information that we've covered, because what we're seeing here is that information just keeps coming up over and over and over again. All right, let's try another one. Let's see, what do I tell you? Actually, I tell you nothing. I want you to determine, I want you to find the value of y that makes this trapezoid isosceles. I want it to be an isosceles trapezoid. Well, here's what we know about isosceles trapezoids. Isosceles trapezoids have, oh, I need an H there, not an A, have congruent diagonals. So, if I'm going to make this guy an isosceles trapezoid, what do I have to do to the diagonals? Set them equal. So here's a great geometry problem for you. I need diagonal JL to be congruent to diagonal KM. Well, in order for them to be congruent, I just need to set them equal to each other. 3y plus 6 equals 22 minus y. Let's go ahead and solve for y. I'll add y to the other side. Subtract 6 over there to the right. 3y plus y is equal to 22 minus 6. I wind up with 4y equals 16. Boom. In order for this guy to be an isosceles trapezoid, the value of y must be 4. Why is that the case? Well, here's why. That means then that JL is 3y plus 6, which is 3 times 4 plus 6, which is 12 plus 6. I get JL is equal to 18. What about KM? Well, KM is 22 minus 4. Actually, y. Plug in the 4. 22 minus 4. And of course, 22 minus 4 is 18. And in order for it to be an isosceles trapezoid, those diagonals must be congruent, which they are. All right, guys, head on over to the next page of the notes. We're going to take a look at one more property having to do with trapezoids and a couple of example problems that go along with it. So I'll meet you on the next page.